No cities, no writing, no wheel yet that comes 500 years later from these same people. A few thousand individuals living in the open steppe. Archaeologists today call them the Caucasus Lower Volga Group, or CLV for short. They left no monuments, no art we've found, no name for themselves in any record. But in February of 2025, two landmark studies published simultaneously in the journal Nature, led by Dr. Iosif Lazaridis at Harvard Medical School, analyzed the ancient DNA of 435 individuals from across Eurasia. And the conclusion was, by the standards of this field, decisive. Those CLV people on the steppe were the original speakers of Proto-Indo-European, the ancestor language of English, Spanish, Hindi, Russian, Persian, Greek, 400 languages, 3.5 billion living speakers. All of it traces back to a few thousand people on a grassland between the Volga and the Caucasus. Think about that for a second. Every grammar lesson you ever sat through, every language you've ever tried to learn, every word your family has spoken to you in your native tongue, if that tongue is Indo-European, it was shaped by people who lived before the wheel existed, in a place most people today couldn't find on a map. Now, everything you just learned about the rival theory, the one that said Indo-European languages, came from ancient Turkish farmers? Hold on to it, because it's about to mean something completely different. For 60 years, a competing idea called the Anatolian hypothesis argued that Indo-European spread westward with the first farmers out of what is now Turkey around 7000 BCE. That was the dominant academic framework. It was in textbooks. It was the safe answer. And the 2025 data didn't just challenge it. It showed that the Anatolian Indo-European speakers had also descended from a separate CLV migration into Anatolia around 6000 BCE. The Turkish farmers didn't teach the steppe people their language. The steppe people, or their cousins, had already arrived in Anatolia before the farmers even got started. The entire debate was structurally upside down. The people who eventually carried this language west into Europe were the Yamnaya direct CLV descendants. We know their burial practice exactly. Single grave mounds called kurgans, one man interred with horse bones, wheels, and red ochre powder staining his skeleton. Archaeologists have mapped over 5,000 of these sites, stretching from Ukraine to Kazakhstan. And within 300 years of their westward expansion, beginning around 3000 BCE, the genetic profiles of Central European populations were unrecognizable. Entire pottery traditions vanished within 3 generations. In what is now Britain, genetic analysis of burial sites from around 2400 BCE shows a 90% replacement of the existing gene pool. In less than 3 centuries, every language you know carries the architectural signature of those people. Every language, except one. And that language predates the language family that tried to replace it. If Euskara predates the Neolithic, then someone was speaking it before the farmers arrived. And to understand who those people were, you need to understand what happened when the first wave reached Europe, because it wasn't the Yamnaya. Someone else got there first. Çatalhöyük, south-central Anatolia, 7,400 BCE. 8,000 people living in what may be the oldest true city on Earth. And they had a burial practice that archaeologist Dr. Ian Hodder of Stanford University has described in one sentence: "You're walking on your ancestors." The dead weren't put in cemeteries or fields. They were buried beneath the floors of the houses. Families ate, slept, and raised their children directly above the people who came before them. For 1,400 consecutive years, without interruption, they maintained this practice. These were the early European farmers, EEF, in the genetic shorthand. They left Anatolia around 6000 BCE and spread across Europe, bringing agriculture, pottery, and a language. That language has never been reconstructed. It is completely gone. The people who replaced them made sure of it, though not in the way you might picture. Dr. Iñigo Olalde, at the Institut de Biologia Evolutiva in Barcelona, spent years analyzing the genomic history of the Iberian Peninsula across 8,000 years of burial sites. What he found was a specific pattern. Around 2500 BCE, Bell-Beaker-associated migrants carrying Yamnaya ancestry, and the male Y chromosome haplogroup R1b arrived in Iberia. Within approximately 200 years, they had replaced virtually all of the preceding male lineages on the entire peninsula. Every man who had been buried in Iberia for the previous 3,000 years, his genetic line was gone, replaced. And the transition period burial sites tell you exactly how it happened. Steppe ancestry men, local EEF ancestry women, over and over again. Steppe men, local women, steppe language. That was the mechanism. That was the engine of the entire expansion. Here's the thing about modern Basques. They carry unusually high levels of EEF ancestry, the genetic signature of those first farmers. But they also carry elevated pre-agricultural Western hunter-gatherer ancestry that other Iberian populations lost almost entirely. The Basques aren't a pure remnant of one ancient group. They are a preserved ratio, a specific blend of the people who were in Iberia before agriculture and the first farmers who followed that has not significantly shifted in 2,500 years. Stay with me because this next part is the reason this video exists. The steppe expansion had a mechanism, a repeatable, consistent, almost algorithmic structure. It required social access, steppe men gaining reproductive access to local women, and that mechanism works unless something prevents the social access from happening in the first place. The Romans had roads through Basque territory. The Visigoths had garrisons. The genetic record shows zero admixture from any of them inside the Basque population. Zero. The mountains didn't do it. Geography didn't do it. Something else held the line. And the 2021 study was about to show exactly what it was. Because for decades, everyone pointed to the Pyrenees as the barrier. Dr. Flores-Bello's data said otherwise. The Basques live on the western end of the Pyrenees, the lowest end, the least geographically isolated part of the entire range. The barrier wasn't a mountain. It was a sound, a grammar, ISO, and a language with no relatives and no known origin, and it was hiding something inside itself that no one had looked for until now. That fortress had an architecture, and when Dr. Flores-Bello's team looked inside it, they found something nobody expected. They were running a standard population structure analysis. Take the 629,000 genetic marker positions per person. Map the individuals onto a genetic landscape. Look for clustering groups of people who are more similar to each other than to the wider population. In a normal European study, you'd expect to see clusters that match large geographic regions, countries maybe, broad ancestry groups. What they found in the Basque country was genetic clustering at distances of 10 to 20 kilometers. Villages separated by a 40-minute drive were showing statistically significant genetic differentiation from each other. That doesn't happen. Not in modern Europe. Not with populations that have lived alongside roads and trade routes for centuries. And then they laid the Euskara dialect map on top of the genetic map. The boundaries matched. Precisely. The genetic clusters aligned exactly with the dialect zones of the Basque language. Euskara has 8 dialects, Biscayan in the west, Guipuzcoan in the center, Lapurdian and Navarrese Lapurdian across the French border, Zuberoan in the far east. These dialects are not just different accents. In some combinations, they are genuinely difficult to understand across. A speaker of Zuberoan and a speaker of Biscayan, separated by 150 kilometers, they communicate with real effort. And those two dialect groups were, according to the genetic data, also the most genetically differentiated from each other within the Basque country. The language didn't just keep outsiders out, it kept insiders apart. There are 3 things this study revealed. The third one is the one that ends the debate. First, the Basques' genetic isolation is real and measurable down to the village level. Second, it correlates with linguistic boundaries, not geographic ones. Third, and this is the one it means, the Yamnaya expansion mechanism was not blocked by terrain. It was blocked by a social structure that Euskara created and maintained. The mechanism required social access, steppe men gaining entry into local communities through marriage. Euskara, by defining who was us and who was them down to the level of which valley you came from, made that entry structurally impossible. Not in one dramatic act of resistance, in every generation, across 2,500 years. Every time, a young person chose who to marry. Take the village of Zugarramurdi, 200 people, sits on a main road, and yet parish marriage records going back to the 17th century show endogamy rates of people marrying within the community consistently above 80%, not because of law, not because of geography, because the language defined the boundary of who you were. Actually, here's something I want to bring up. If you watched our last video on why the Basques stayed genetically frozen for 3,000 years, you already saw the edge of what we're describing now. What surprised you most about that one? Drop it in the comments, because what we're about to show you next is the thing that video was building toward, and it reframes the entire question. Because here's what that means for every language that was erased during the Yamnaya expansion. Those languages didn't just lose their words. They lost the social boundary that kept their speakers genetically distinct. The moment a language stopped being the wall between us and them, the mechanism completed. Those languages weren't simply replaced. They were unlocked. And here is where the 2025 nature data does something unexpected. The CLV people, the original Indo-Europeans, were also a small, isolated group. They were also linguistically distinct from everyone around them. The difference between the Yamnaya and the Basques is not that one had a stronger cultural identity. It's that one had horses, and the other one didn't. The horses changed the math entirely. The Yamnaya had domesticated horses by 3,500 BCE. They had wheeled vehicles. They could move a family's entire household 30 kilometers in a single day. Their expansion wasn't a slow drift. It was a logistical revolution, a completely new way of moving across the world, and the language went with them because they went everywhere. By February of 2025, the genomic evidence had caught up to the scale of that story. Dr. Lazaridis and David Reich's team at Harvard, working alongside dozens of international researchers, analyzed 435 ancient genomes. The Harvard Medical School press release called them landmark studies. The word used internally in the research was decisive, and for about 40 seconds here, the mystery really does feel solved. The steppe hypothesis confirmed. The origin point locked in. The mechanism understood. I want you to actually feel that resolution for a moment, because you've earned it. And yet the data said the exact opposite of what everyone expected when it came to the one living population this model should explain most cleanly. Dr. Guus Kroenen is a professor of linguistics at the University of Copenhagen and Leiden University in the Netherlands. He was one of the lead linguistics collaborators on the 2025 study, and while everyone was celebrating the confirmation of the steppe hypothesis, Kroenen said something that got very little coverage. He said, "Language is transmitted socially, not biologically. There isn't necessarily a direct link between language spread and population replacement." Read that again slowly. 2 papers in Nature, 435 ancient genomes, the most powerful ancient DNA study in the history of the field. And one of its own linguistics leads is saying, this proves who moved. It doesn't prove why the language spread instead of dying. And the Basque problem is still sitting there, unresolved, right at the center of the solution. If the Yamnaya language spread because they genetically replaced local populations, why did the Basques, who were partially replaced in ancestry, keep their non-Indo-European language? And if genetic dominance explains language survival, why is the genetically exceptional Basque population's language also surviving? The 2 cases prove opposite things, using the exact same evidence. That's not a minor footnote. That's a crack in the foundation. There's another population that makes this worse. The pitted ware culture, maritime hunter-gatherers, who lived in Scandinavia, starting around 2,800 BCE, genetically unrelated to either the Yamnaya or the first farmers. They coexisted with Yamnaya-descended corded ware populations in Scandinavia for approximately 600 years. Genetic data from that entire period shows almost zero mixing between the 2 groups. 6 centuries, side by side, barely any admixture. Then the pitted ware people disappear. Completely. No language descendants, no identifiable cultural continuation, no name in history. Dr. Pontus Skoglund at the Francis Crick Institute in the UK has described their genetic endpoint as one of the most complete population turnovers in ancient European genomics. We don't know what happened to them. The genome is the only evidence they ever existed. But here is the ghost that nobody expected to find. Ancient DNA from hunter-gatherers in northern Spain from a cave site called La Braña in León, dated to approximately 7,000 years ago, shows a Western hunter-gatherer genetic signature that is most closely preserved among all living Europeans in modern Basques. These people were in Iberia before agriculture, before the Yamnaya, before everything the 2025 papers were built on. They spoke something. We have no record of what it was. And their genes are still walking around the Western Pyrenees today, going to community meetings, speaking Euskara. The ghost didn't stay in the cave. That cave is called La Braña Arintero. It's in the Valdelugueros Valley in León, northern Spain. In 2006, archaeologists excavating an acidic peat deposit found two Mesolithic skeletons in exceptional condition. They named them La Braña 1 and La Braña 2. In 2014, Dr. Carles Lalueza Fox at the Institut de Biologia Evolutiva in Barcelona published the fully sequenced genome of La Braña, 1-inch Nature. And what that genome showed stopped people cold. The man had dark skin, blue eyes. He died approximately 7,000 years ago. And he is among all ancient individuals ever sequenced the closest genetic relative to the modern Basque population that we have found. He spoke something. We have no idea what it was. This discovery was published in 2014 in Nature, one of the most prestigious scientific journals on Earth, and the implications sitting in the supplementary data has barely been discussed in the decades since. Until now, Dr. Lalueza Fox's analysis showed that La Braña, one's Western hunter-gatherer ancestry, is preserved in modern Basques at levels between 35 and 50%, significantly higher than in any other modern European population, all of which diluted their hunter-gatherer signal through thousands of years of mixing with farmers and steppe migrants. His genome is the earliest confirmed genetic ancestor of a living European language community, a man who died before pottery, before farming, before any of the civilizations we teach in schools, and his DNA is in people alive today. Now, here's where it gets genuinely strange. Dr. Joseba Lacara, one of the foremost specialists in Basque historical linguistics at the University of the Basque Country, has spent decades analyzing the structural roots of Euskara. What he and other specialists have found is that the language's verb architecture, its root morphology, its basic grammatical skeleton, shows no borrowing patterns from Neolithic agricultural vocabulary. None. The linguistic fingerprints of farming the words for grain, for domesticated animals, for permanent settlement that you find embedded in most European languages don't appear in Euskara's deepest structural layers. No responsible linguist is claiming that Euskara directly descends from whatever La Braña once spoke. That would be impossible to prove. But the question it raises is one that current methodology cannot answer. Is Euskara's grammatical core the echo of something 8,000 years older than its oldest written words? Did the grammar survive even when the vocabulary changed? Is the structure of the language itself a kind of fossil? And then there's La Braña too, the second skeleton from that cave. He has two injuries. A healed blade wound to one rib. He survived a fight at some point in his life. And an unhealed trauma to the skull, a blow that killed him. He was murdered. He left no traceable descendants. La Braña 1 survived and did. The difference between a genetic legacy that reaches 750,000 living people and a complete dead end was, in this specific case, one man surviving a fight that his companion didn't. That asymmetry, one man lives, one man doesn't, is written into every Basque genome alive today. What was lost when the Yamnaya expansion erased the languages around it isn't just words. Languages don't just carry vocabulary, they carry ways of seeing, spatial reasoning systems. ways of organizing kinship, ecological categories that can't be directly translated into another language's grammar. When those languages stopped being spoken, those ways of thinking became permanently inaccessible, not stored somewhere, waiting to be recovered. Gone, the way an oral system goes when the last person speaking it falls silent. And then buried in the Flores-Bello 2021 supplementary data, something that almost nobody reported. The genetic differentiation between Basque dialect communities appears to be increasing over recent centuries, not decreasing. As the number of Euskara speakers has fallen, the intensity of genetic isolation within the remaining speaker communities has grown. The language, as it contracts, is concentrating. No published study has explained why. A wall concentrating, even as the language thins. Think about what that means practically. A 2023 sociolinguistic survey by the Basque government's own research cluster found that among Basques under 30, fewer than 40% speak Euskara as their primary daily language. In the coastal cities Bilbao, San Sebastián, Bayonne, that drops below 25%. The language that held for 2,500 years against Roman roads, Visigoth armies, Carolingian expansion, and centuries of deliberate suppression is now losing ground to something that requires no army, no policy, no violence, just smartphones, just Spanish-language television, just the ordinary gravity of living in a modern city where the majority language is not yours. Dr. Flores-Bello's team modeled what happens genetically if those trends continue. If urban endogamy rates keep declining at roughly 0.5% per generation, which is the current trajectory, measurable genetic homogenization with surrounding Spanish and French populations will appear in genomic data within 8 to 12 generations, 200 to 300 years. The wall that took 2,500 years to build could dissolve in 1/10 of that time. What they found in the modeling changed how we understand the entire timeline, because it means we are living inside the last observable window, right now. Not in 50 years, now. The 2021 COMAS study may be not just the paper that proved the mechanism, it may be the last study that can fully observe it in operation at scale. Future geneticists studying the Basque population will do what researchers today do with the pitted ware culture, reconstruct an endpoint from a genome that no longer has living parallels. They will look back at these years as the last moment the wall was standing. In 2012, the Basque government launched a program called Euskara Munduan Basque in the World. Language courses, offered in 12 countries, targeting diaspora Basques in Uruguay, Argentina, Chile, Mexico, the United States. Within 3 years, 4,000 people enrolled. Many of them have no meaningful Basque genetic ancestry anymore. Their families intermarried over generations of diaspora life. They are learning the language that, had their ancestors kept speaking it, might have kept them genetically Basque. They are rebuilding a wall they don't know was ever functional, with genuine enthusiasm, without any idea what it was built to do. And yet the rural communities, the ones where Euskara speaker rates stay above 70%, are showing greater internal genetic isolation than in previous sample periods, not less. As the language retreats from cities, it concentrates into mountain villages. It becomes more potent in the places it still lives. It is not dying evenly. It is pulling back into itself. And then there's this. A population genetics analysis cross-referenced in the Flores-Bello supplementary citations identified a small cluster of individuals who self-identified as ethnically Basque. They spoke Euskara fluently. They had Basque surnames traceable 5 generations back. Their genetic profiles were statistically indistinguishable from northern Iberian non-Basque populations. Researchers flagged it as possible sample error. It wasn't. The language had absorbed them. The identity had absorbed them, but their genetics had not followed. The mechanism that spent 2,500 years keeping people out had, in their case, let them in. The wall works both ways. Absorption is how it ends. And we know that because this exact sequence has already played out in a completely different part of the world, with a completely different people, following the same steps so precisely that it is not a parallel. It is a mirror. Hokkaido, northern Japan, 1869. The Meiji government opens the island to large-scale Japanese settlement and calls it development. Within 30 years, the Ainu people, the indigenous population of Hokkaido, with a language and a genetic profile unlike anything else in East Asia, are legally erased. Their language, Ainu Itak, is banned in schools, their cultural practices are outlawed, and the genetic signal that had made them distinct from Yamato Japanese for thousands of years begins to blur. In 2020, Dr. Takashi Gakuhari and colleagues published an ancient genomic study in Nature Communications that sequenced ancient Jomon individuals and compared their profiles to modern Ainu. What they found: the Ainu carry Jomon ancestry, the pre-agricultural genetic signature of the original Japanese archipelago inhabitants, at levels above 70%. Yamato Japanese carry about 12%. The gap between those two numbers is the same gap that separates Basques from other Iberians. And the reason for that gap is identical: linguistic isolation maintained endogamy, which preserved the ancient genetic signal across thousands of years of contact with expanding populations. Ainu Itak is a language isolate, no known relatives anywhere on Earth. Just like Euskara, the Ainu population carried anomalously high pre-agricultural ancestry, just like the Basques. Their genetic distinctiveness correlated with linguistic boundary maintenance rather than geographic isolation, just like the Basques. They experienced extreme replacement pressure from an expanding agricultural and administrative population, just like the Basques. The geometry is the same, 8,000 miles apart, separated by millennia of independent history. These two populations independently arrived at the same solution to the same pressure: a language that functioned as a biological barrier without anyone designing it to do so. In 2019, the Japanese government officially recognized the Ainu as an indigenous people of Japan, 150 years after Hokkaido was annexed. By that point, the number of fluent native Ainu Itak speakers was estimated at fewer than 10. The language has no children speaking it natively today. The genomic wall that protected Ainu genetic distinctiveness for thousands of years did not collapse when the Meiji army arrived. It collapsed when Ainu children stopped answering questions in Ainu Itak. The Basques have 750,000 speakers. The Ainu had 10 fluent elders in 2019. The distance between those two numbers is not a comfort. It is a timeline. And then there is this. In 2017, a pre-publication genomic study of Ainu individuals was withdrawn from a Japanese university database. Ainu community representatives objected that the research had been conducted without proper informed consent. The data, which reportedly showed Jomon ancestry levels higher than any previously published figure, potentially rewriting the timeline of Japanese prehistory entirely, has never been republished. It exists only in references within other papers. The study is gone. What the genome remembers is not just ancestry, it remembers catastrophe. In 2018, Dr. Johannes Krauss, director of the Max Planck Institute for Evolutionary Anthropology in Germany, published work showing that the genomic signature of the plague of Justinian, which swept through the Byzantine Empire beginning in 541 CE, is detectable in European populations as a measurable reduction in genetic diversity. A catastrophic mortality event left a scar in the DNA of entire populations, not as a story, not as a cultural memory, as a statistical signal in allele frequencies, a population that was suddenly and violently smaller, rebuilding from a narrower genetic base. The genome remembered. And that raised an inevitable question about the Basques. What does their genome remember? The Flores-Bello 2021 study identified a specific population bottleneck in Basque genetic history. It occurred approximately 2,500 years ago in the Iron Age. Before this point, the Basque genetic profile showed normal levels of European diversity. After it, that diversity contracted. Something happened around 500 BCE that significantly reduced the founding population of what would become the genetically isolated Basque community we can still measure today. The survivors rebuilt, and they rebuilt inward into tighter and tighter endogamy, using the one institution that remained intact: the language. Before that bottleneck, the wall wasn't as high. After it, the wall became absolute, which means Euskara didn't just maintain the boundary across 2,500 years of history. It built the boundary out of a catastrophe we cannot identify and held it from that point forward. The Roman writer Strabo, writing around 7 BCE, describes the Vascones of northern Iberia this way. They live in the mountains, they speak an incomprehensible language, and they refuse to integrate with Roman administrative culture, despite Roman roads running directly through their territory. He names this specifically. Every other Iberian people he describes has adopted Latin names, Latin commercial practices, Latin social structures. The Vascones did not. Even under Roman occupation, even with roads, garrisons, and the full administrative weight of the most powerful empire in the Western world, the mechanism held. This brings everything to a single point that has no comfortable resolution. The Basques did not survive because they were geographically sealed off. They did not survive because they were militarily superior. They survived because at some moment of catastrophic reduction somewhere around 500 BCE, when the population contracted to a new, smaller base, their language became the only institution left standing. No temple, no empire, no army, just Euskara. And Euskara, by being structurally incomprehensible to everyone outside it, by fragmenting social access, not just between Basques and outsiders, but between Basque village, and Basque village built a wall that nothing in the subsequent 2,500 years could bring down. We don't know what that catastrophe was. A plague, a war, a famine? The archaeological record is silent. The historical record doesn't mention it. And yet the genome says it happened. It says something terrible occurred. The population shrank, and the survivors made a choice. Not a conscious choice, not a planned one, but the kind of choice that cultures make in extremity. They held on to the one thing that made them themselves. The event that shaped the genetic fate of 750,000 living people is invisible to us. It happened. The DNA says so, and we cannot find it. That is what the genome remembers, not the recovery, the scar. And somewhere in the hills above Zugarramurdi, in a village of 200 people on a main road, the scar is still there, measurable, active, and getting quieter every year. There's a war that started 4,000 years ago. It never ended. You just can't see it anymore. It doesn't have soldiers. It doesn't have borders that change on a map. It's fought in classrooms, in kitchens, in the choice a 22-year-old makes in Bilbao about which language to use when she texts her friends. It's fought every time a child answers in Spanish, because it's easier. Every time a village loses one more fluent speaker to a city. Every time the genetic data from a rural Basque community shows quietly, in a supplementary table nobody reads, that the differentiation is still there, still measurable, still real. The Yamnaya started moving west around 3000 BCE. Their language replaced everything it touched. In Britain, in France, in Iberia, in Scandinavia, within 2 to 3 centuries of arrival, the old genetic profiles were gone, the old languages were silent, and the new order was so complete that we only know the previous world existed because ancient DNA started talking to us in the last 20 years. That wave reached the Western Pyrenees, and it stopped. Not because of a mountain, not because of a battle anyone recorded. It stopped because of a language that had already survived something so catastrophic, that Iron Age bottleneck, around 500 BCE, that we still cannot name or locate, that it had become something harder than stone. A social architecture so complete, so internally partitioned, so structurally incomprehensible to outsiders that the mechanism simply had nothing to grab onto. And here is the thing that should stay with you after this video ends. The Yamnaya expansion is the reason you speak the language you're hearing right now. English is a Yamnaya language. So is every language this video will ever be translated into, except one. Every grammar rule you learned in school, every way your mind organizes time and action through speech, every language your children will grow up speaking. If it's Indo-European, it comes from that grassland between the Volga and the Caucasus, from people who domesticated horses before the wheel existed, and then used those horses to rewrite the genetic and linguistic map of the world. You are, in your language, a product of that expansion. Most of humanity is. And somewhere in a village of 200 people on a road in northern Spain, 750,000 people are speaking the language that wasn't, the language that looked the expansion in the face and didn't move, the language whose grammar may be older than farming, whose speakers carry the genes of a blue-eyed hunter who died in a cave in León 7,000 years ago, whose internal dialect boundaries are still producing measurable genetic differentiation at distances of 10 kilometers in the 21st century. But the data says the wall is thinning, not everywhere, not evenly, but it is thinning. The cities are winning the way cities always win, not through force, through gravity, through the ordinary pull of a world where the majority language is everywhere and your language is somewhere. Dr. Flores-Bello's team found that the genetic differentiation is concentrating into the rural strongholds even as it fades from the cities. The language is retreating into the places it has always been strongest. The mountains, the small villages, the communities where the Auslan still meets, and the decisions are still made in Euskara. We don't know what happens next. That is not a rhetorical device. We genuinely do not know. The models say 200 to 300 years before genomic homogenization becomes measurable in the data. But the models also said the Basques should have been absorbed 2,000 years ago, and they weren't. The models have been wrong about this population before. What we do know is this: the Iron Age catastrophe that created the Basque genetic singularity has no identified cause, no known plague, no confirmed war of sufficient scale, no famine in the archaeological record that matches the bottleneck's timing or geography. Something happened around 500 BCE that changed the genetic trajectory of every Basque person alive today, and it is completely invisible to us. The event that made the wall is gone. The wall remains. And somewhere in a mountain village, a child is deciding right now which language to answer in. The genome will remember that choice. It always does.